at this problem. It's very simple. I believe from the previous class we just had now, you can just get how to go about this. But let's look at it and see what it is. It says, how many moles of sulfuric acid? Sulfuric acid is the same thing as tetraozosulfate 6 acid. You should know. Sulfuric acid is the old name, while the IUPAC name is tetraozosulfate 6 acid, right? So why is it called an acid? It's called an acid because it will always liberate hydrogen when you dissolve in what? Water. Okay? So sulfuric acid are contained in 0.80 liters of 0.05 capital M. The capital M there stands for molarity or concentration in mole per dm cube. Okay? So solution of sulfuric acid. Okay? So to go about this, you have to know what this value is and what this value is. Okay? Now, look at the question very well. What does this look like? Volume, right? Liters. What does it look like? C, that is the molarity or the concentration in mole per dm cube. Recall that we said that C is equal to N over V, where this is not given, right? We are looking for it. Mole. The V is the volume. The C is this. So what do you do at this case? We make the N subject of formula. So N will be equal to what? C times V. So N will be equal to what? 0.05 times 0.80. So what do you have? 0.04 moles, right? That's exactly what you are going to get. So this is the number of moles present in that value. Look at example number 2, okay? Example number 2, right? Number 2. So, what mass of iodine is required to make 5 times 10 to the power of 2 centimeter cube of 0.250 molar solution of iodine? Okay? So this is the molar mass of iodine. Iodine is a diatomic gas or element, so it has to be I2. So each iodine is 127. So 127 times 2 gives you 254 grams per mole. So how do we attempt this question? What mass? We are looking for the mass in grams. This is definitely the mass in grams. Okay, there's a difference between mass concentration and mass in grams. The mass is just talking about the anhydrous mass, that is the mass that has not been dissolved in any solution, right? A dry mass. So how do we find this mass? We start from somewhere. From what they gave us, we are given the volume, right? The volume was given 5 times 10 to the power of 2. It's the same thing as 500 centimeter cube. Okay? But we said that the volume must be in what? dm cube and not centimeter cube. So how do you convert from cm cube to dm cube? You divide by what? 1000. So this will give you, we definitely have 0.5 dm cube, which is the unit in dm cube, right? 500 over 1000 gives you 0.5. Then we know the C. The value for the C is 0.250 capital M. We are looking for the what? The mass. We know that if we can get this N first, remember that N is C times V. If I can get this N, then I can revert back to N is equal to mass over molar mass. This equation can help us get the mass. If we can get this N using these two values, we plug in this value here, make the mass subject, we get the mass. The molar mass was given 254. Okay? So let's quickly solve. I can divide the board into 2. So we have that N is equal to, remember that N still remains number of moles. N becomes 0.250 times the volume, 0.5. So N will be equal to, multiply these two things, 0.250 times 0.5. You get the value of what? N. All you have is 0.125 moles, right? That's not the answer. We are looking for mass. So from here, making the mass subject, mass becomes N times molar mass. What is N? N represents mole, it's not so? So mass becomes this value, 0.125 times 254. So whatever you have here, your mass will become 31.75 grams. So that is the answer. Now take a look at the question on the board. What volume of 0.08 molar solution of HCl will be required to neutralize 25 centimeter cube of 0.02 molar solution of sodium triisocarbonate 4 solution? So from this question, you will notice that there is a what? A reaction called neutralization reaction taking place. So neutralizes. Okay? So the reaction is definitely involving an acid and a carbonate, right? The carbonates are those compounds that always end with CO3, triisocarbonates, okay? We have bicarbonates too, but this is a triisocarbonate, right? Okay? So this compound, whenever it reacts with an acid, it forms three things. Watch. When you react HCl plus carbonates, okay, you have your salt, which is going to be sodium chloride, your water, and a gas is always given out. The gas is what? Carbon 4 oxide. This gas is given out. Okay? So balancing this equation, you have to put 2 here to balance the sodium. Balance the metal first. The metals first, the non-metals, and then hydrogen and oxygen last. Okay? So metal is 2, it is 2 here. So chlorine is 2. How many should I put here? 2. Why? Because I have 2 of this guy. I need to balance it 2. Hydrogen is now 2. Hydrogen is 2. Balance. Carbon is 1. Carbon is 1 here. Balance. Oxygen is total of 3 here. And we have 1 plus 2, 3. Balanced. So the equation is balanced. So why do we balance the equation? So we can be able to know how many moles of this guy is reacting with this guy. So remember that this is acting as this is the acid, this is acting as the base, right? So now I told you about the equation that works for this. Okay? If you notice, let us outline the parameters that was given to us. What volume? We are looking for the volume of this guy, the acid. So we are looking for the volume of the acid. We are looking for this. But they gave us the Ca. The Ca is 0.08 molar solution, right? Neutralizes 25 centimeter cube of this. So this is the Vb. The volume of the base is 25 centimeter cube. And also they gave us the Cb. The Cb is 0.02 molar solution, right? We know this, right? This is your Na. This is the Na. Na is equal to 2 moles. Nb is equal to 1 mole. Please, anytime we are making use of this formula, CaVa over CbVb is equal to Na over Nb. Anytime you are using this equation, don't convert the volume. I know we normally convert the volume if we are making use of just the normal C equal to N over V. But for this one, do not convert this volume to dm cube or liter. Do not convert. The reason why we are not going to convert is because whatever we get for the one we are looking for, which is the Va, whatever we get here will still be in the same unit of this. Okay? Or if they are in the same unit, they will cancel out. They will not have any effect in the equation. So please do not convert the volume whenever you are trying to solve with this. So I will quickly make what? The Va subject of formula. This Va, making it subject, means that I will cross this way. The one that multiplies this will be at the top. So we'll have that CbVb Na divided by the two things that are touching the VA, which is what? CA and B. Right? So I can now plug in the values. CB was from the question, look at it here, 0.02 times, what is VB? 25, don't convert, 25 times, what is Na? Number of mole of the acid from the equation, which is what? 2. So we have 2 here, divided by, what is the Ca? The concentration of the acid in mole per dm³, that is 0.08 times, what is the number of mole of the base? 1. So by the time you punch this, whatever you get becomes the answer. Make sure you punch it correctly. So I believe that you have 12.50 centimeter cube. That is the volume of the acid that was able to neutralize that base of 25 centimeter cube.